Now, a mixture. A mixture is simply two or more substances that are placed together, but they're not chemically combined. If you are not chemically combined, what does that mean for you? What can you do to it?
Separate it.
You can separate it. Very good. Okay? Now, we have certain types of mixtures. Okay? In a heterogeneous mixture, again, you have your substances. If you take a sample from the top, the middle, and the bottom, you're going to get a different composition throughout. You do not have a uniform composition. In a homogeneous mixtures are also called solutions. In a homogeneous mixture, you are going to have the same composition throughout your sample or throughout your substance. Do we get that? Yes.
For example, salt water, right? The salt water has the same taste throughout the top and bottom. What do you say? What do you say is that homogeneous or heterogeneous?
You tell me. If you say you taste it from the top, the middle, and the bottom, and it all tastes the same, so which one is it going to be?
Well, in this, it sounds like homogeneous, but it comes to different type of compounds. It contains salt and water.
It's a salt and water,
Yeah.
but okay, what type of, what's the state?
State is liquid.
No. Remember, liquid is a
okay.
pure substance,
Okay.
right? Liquid cannot have anything else in there. But if you have salt and water mixed together, what's the state there? Aqueous. Good. So in an aqueous solution, you're going to have what type of mixture? Again, if you taste it and it tastes the same, the top, the middle, and the bottom, what do you have? Homogeneous. Get that?
Yeah.
Okay. Now, classifying matter again. Matter can either be a pure substance or you can have a mixture. If you have a pure substance, you only have an element and you have a compound. Now, if you look at a compound, this is sugar. Sugar is sucrose. Sucrose is a combination of two sugar molecules, glucose and fructose, right? You have hydrogens, you have oxygens, you have carbons, all right? But they're all the same. You're going to have the same molecule throughout, all right? Here you have your element. Your element, again, even though this is a copper piping, here is only copper. That's a pure substance. Now your mixtures can either be a heterogeneous mixtures. Here you have oil and water. Oil is something called hydrophobic, meaning it doesn't like water, so it's going to run away from it. So this way you're going to have let's bring it home, all right? When your mom sends you in the kitchen, say, Juan, go make me some pasta. What do? You have water and the noodles don't stick. So your oil and your water. When you add your oil to your water, what do we see? What happens? What does it look like? Stays at the top, and what does it do? It comes in that little bubble, little circle. This is what's happening. The oil is going to come in and be with itself. This is why you're going to get two separate layers. All right? Here you have, this is at the interface. You have your oil layer and you have your water layer. Your homogeneous mixture, your soft drinks that you drink, your little Coca-Cola, okay? All of this is inside of here. You have your carbon dioxide gas, your water, your sugar, your coloring, all the other crap they put in there. Okay? Everything is going to be the same throughout. If you take a sip from the top of your soda, the middle of the soda, the bottom of your soda, it all tastes the same because everything is evenly mixed in there. Did we get that?
So only when it's not evenly mixed is heterogeneous.
Yes, when you can see separate layers, it's going to be heterogeneous. Now, we have types of separation, right? Because these mixtures are not chemically combined, you can separate them. If you look here, if we pay attention to just this Erlenmeyer flask, this Erlenmeyer flask has like a yellow solution in there. This here, this white piece here, that is called filter paper. Filter paper is a special type of paper that has little pores in it that is only small enough to let very small molecules through.
Use that in coffee, right? The coffee makers?
Yes, you can think of it as like a coffee filter too, okay? It's going to allow your water or your liquid to pass through, but anything bigger, any type of solid is going to catch in your filter paper. All right? So here, you see that you start off with a yellow solution, and in your beaker, you're going to end up with a clear, colorless solution, because you have separated out the yellow residue in your filter paper. Did we get that? All right, good. Now, distillation. Distillation has to do with the differences in boiling points. All right? So here, you have a mixture of salt water. Here you have a condenser. When you heat something up, what's going to happen? That's alcohols and certain things with complex structures. But just in general, when you heat up a liquid,
Decomposes.
it whoop,
Decomposes.
it vaporizes or turns into a gas. All right? Now, once it turns into a gas, how would you get it back?
Condense it.
You're going to condense it. Good. Okay? So here, let's say this right here is a mixture of alcohol and water. All right? What's the boiling point of water? 100 degrees Celsius. Good. The boiling point of, let's say, ethanol, roughly 47 degrees Celsius. All right? Now, when you're dealing with distillation, boiling points are essential. You're going to be able to separate these things based on their boiling points. Now, when you're heating up the mixture of alcohol and water, what's going to happen first? The alcohol will start to do what? It will start to evaporate. When it evaporates, the vapor is now going to come up and pass through this tube. This tube is called a condenser. All right? You can think of it as like, you know those tumblers? You know, where it has like the wall inside and then the outer wall, and it keeps your drink warm or cold? Something like that. That's what this condenser is doing. There's a tube, a hollow tube inside that your gas is going to pass through. There's another tube on the outside that cold water is now going to pass through. That cold water is going to suck the heat out of the gas and turn it into a liquid again. All right? So now, when you're heating up your alcohol and water mixture, how do you get them separate? What exactly is happening?
The different boiling points.
The different boiling points. So when you start your alcohol boiling, how exactly are you going to be sure that you are not mixing your alcohol and your water?
Just keep it at that temperature that part boils at, and don't go to 100, because then you're going to get the water as well.
There you go. So if you maintain the boiling point for your alcohol, you can boil off all of your alcohol first before you now get to the boiling point of your water. Did we get that? Tell me.
Would the weight of the gases be taken into account?
What do you mean weight of gases?
Because the density of water is 1 gram per milliliter. And
Like not in terms of vaporization.
yeah, it's the way it's water.
Okay, so now we have chromatography. Has anybody ever done like tie-dye? Okay? When you do tie-dye, what happens? You see something, what happens? Nobody else did tie-dye? So anybody had no high school days when they did tie-dye for senior season, senior year?
Isn't that when you drop a bunch of paint and water and you just drop your shirt in there and say ta-da?
Well, it's
That
not
stuff?
paint. Like, how you gonna put paint on your shirt? Like, it's normally ink, okay? When you put the ink on and you put your alcohol, it's going to spread out, all right? And you see the different colors that's in the ink. This is kind of what chromatography has to do with. Chromatography has to do with polarity, okay? So, y'all know, if y'all didn't know so far, your teacher's special, okay? I have my own little way of explaining things, okay? See, judgment, I see you, okay? So don't judge me, all right? So chromatography has to do with polarity, okay? If you look here, you have your little dot of ink. Can you see this line right here, where the solvent is going up? As this solvent goes up, it's going to drag with it the type of ink that is compatible with, all right? So as it goes up and up and up, those who are similar to the solvent will go up with it, and those who are not will stay below, all right? If we bring this home, let's say it's Thursday night, Friday night, Saturday night, okay? Going out with your friends. You got 2 types of friends, okay? You got Tommy. Tommy's the type. Tommy go to the club. Tommy post up, like, alright, see that? Looking good. Gonna do that, alright? Then, you got Junebug. Junebug wrote up, oh, we gonna shut it down tonight. Okay? So now you have to choose who you're going to be like. Are you going to be like Tommy? Or are you going to be like Junebug? Tommy? This is what chromatography is about. Who is your solvent more like? Whoever your solvent is more like is going to go with them. So you now have to choose, are you going to be like blue or are you going to be like purple? Okay? So this is the 2 types of thing. This has to do with polarity. We'll get into polarity a little bit later. All right? Just understand that when it comes to chromatography, separation based on like. Who are you more like? Maybe Friday, you're like Tommy. Saturday, you're like Junebug. Okay? Now, do you get that? Questions, comments, inquiries? No? All right. We're switching gears into our math now. Somebody gonna have to keep time for me? 22. All right. Types of measurements. These are our units of measurement that we're going to be working with. Right? Some of these things we have to memorize. You have feet and pounds and gallons. These are our units. Remember, every number that you are given must be attached to a unit. Okay? Now, we have some of prefixes. These prefixes are going to indicate our base unit. All right? So here we have mega, kilo, deci, centi, milli, micro, nano, and pico. All right? Now, how I like to teach this, because you have to memorize these things according to their numbers. I personally, these exponents, I don't like them. Okay? I personally don't like them. I don't like to teach that way. I prefer my whole numbers. Okay? So we have 3 types of measurements, 3 types of base units. what are my three types of base units? Things that we measure normally. There you go. So our base unit is grams. What else?
Centimeter.
No centimeters. Meters. And which one? Tell me? Liters. These are our base units. Alright? Now, above your base unit is your kilo. Below your base unit, that is your, no, we're going to go with milli. Below milli, micro. Below micro, nano. Alright? So now, you have to think, how do we get to these things? From your base. Everything stems from your base. To get to from base to kilo, what do you have to do?
Multiply.
To get to kilo, you must divide
1,000.
by 1,000. To get from base to milli,
Multiply.
you're going to multiply by
1,100.
1,000. Everything is going to be 1,000 base. Everything. To get from base, to get from milli to micro, what do? Times 1,000. To get from micro to nano, what do? Multiply by 1,000. Everything is 1,000 base. Alright? So now, to get from base to micro, what do?
Multiply by 1,000.
No, a million. You're going to add these these zeros. So you have 6 zeros in between your base and your micro, so you must multiply by 1,000,000.
On top of kilo is mega or giga?
It's mega on top of kilo, but we're not messing with mega.
Oh, we not gonna do mega?
No, we're doing kilo, milli, micro, nano. But you must know the ones in between. You must know deci, centi, and so forth. Deci and centi, in between here, you must know that deci is 10, centi is 100. So from base to nano, what do?
Multiply by billion.
Multiply by 1,000,000,000. I'd rather see these numbers, the whole numbers written out, versus the exponents. Okay? Do we get that? No? What part you don't get?
Because, like I know, from the base, when you go to deci, centi, milli, you go like 10, 100, 1,000. So how come it's just 1,000 each time?
But this is not from base. So from milli to micro, that's another 1,000. From micro to nano, that's another 1,000. Do you get that? Kind of. So in the middle, inside here, you have deci, which is 10, centi, which is 100.
And that's from the base.
That's from base. Now base to milli is 1,000. Base to micro is 1,000,000. Base to nano is 1,000,000,000. But each individual one, milli to micro, you have to multiply by 1,000 to get to that. Yes.
From like centi to kilo, would that be divided by 100,000?
Centi to kilo. So if you set that up, right? How you set it? What's my setup?
From centi to kilo, you're gonna want
So you have
centi
here
on the
first.
top,
What's on the top?
centi. So that's centi. Well,
You sure?
1 kilo.
Remember, you told me that you're going from centi to kilo.
so
So kilos on top.
Kilo.
would you want to cancel out centi?
Yeah, so where would it have to be in order to cancel it
Centi
out?
would be on top over there, and centi would be on
Where,
the bottom.
here?
Yeah,
So on the outside,
yeah,
you have centi, whatever, let's just say centigrams,
yeah.
right?
And
You need to go first to where?
to
To the base.
You need to go to base first.
or you need to go to base, and then from base to kilo, you can't just go from centi to kilo.
You can, but I would rather you take it step by step so you can see what you're doing,
Alright,
right?
so
So let's just continue with this. So centi, and we want to end up with kilo.
okay, so from centi to base, that would
So
be,
what goes in here?
100
We'll get to what this means in a second.
on the top. Wait, no, because you're dividing. So 100 on the bottom.
100 what?
Centigrams, and on the top would be 1 gram, and then over there it would be, because you're gonna get grams out of that. On the it would be 1,000. Wait, because from base to kilo. Okay, so the 1,000 on the bottom.
1,000 what?
Kilos. Kilo. Wait, 1,000.
Grams, because it needs to cancel now, right?
Okay, yeah, I see.
And what's on top?
1 kilogram. Yeah, because that's what you need with that.
Here you go. You get it now?
Yeah.
Alright, so all the units that we have, these are our abbreviations. You must know your abbreviations. These are the units that we are going to be using. Kilograms, kg, meters for length. Mainly for mass, we start off with grams. We don't start off with kilograms. Write it down, Natalia. Write it down.
No, in case you just.
Seconds is S or SC. We have temperature, which is Kelvin. We have substance, which is mole. Mole is MOL. We don't really deal with ampere or candles. Right? And again, this here, you must memorize this. This jumping, how to get from base to kilo, base to milli, base to micro, base to nano, and each individual ones, you must memorize that. All the other ones I will give to you, but that base, I'm not going to give to you. You must know that. So conversions like meters to miles, I'll give that to you. But I'm not going to give you days to seconds. You can figure that out. Okay? Now, these are types of conversions. Your measurement of volume. Measurement of volume is based on a cube, right? What you need to memorize from here is that 1 decimeter cubed is equal to 1 liter. Also, 1 centimeter cubed is equal to 1 milliliter. This is what I want you to say. You must remember these two. These two conversions, must remember them.
1 decimeter cubed.
1 decimeter cubed is equal to 1 liter. 1 centimeter cubed is equal to 1 milliliter. So now, in terms of our density of water, I can tell you that your density of water is 1 gram per centimeter cubed. And you must know that that also equals to 1 milliliter. Okay? Now temperature scale. Temperature scale, we have 3 temperature scales. We have Kelvin, we have Celsius, and we have Fahrenheit. Now, all of these have their own measurement of, but they're all, you can convert in between all of them. Alright? So here, you have water freezes at 0 degrees Celsius, which correlates to 273 degrees Kelvin, which is also 32 degrees Fahrenheit. Water boils at 100 degrees Celsius, which is 373 Kelvin, or 212 Fahrenheit. Alright? We have to be able to know how to convert in between all 3 of these. Now, your temperature, your Kelvin and your Celsius is the ones that we normally use in chemistry. We hardly ever use Fahrenheit. Celsius scale is based on the properties of water. You have water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. Kelvin is based on the properties of gases. The properties of gases, there's no negative Kelvin. There's something special about the Kelvin. What do you have? It's something, starts with an A. 2 words. Starts one starts with an A, other one starts with a Z. The absolute zero. What happens at absolute zero? All motion stops. Okay? All motion stops at absolute zero. Therefore you have no negative Kelvin. Alright? Now, these are the conversion factors for your Fahrenheit to Celsius, Celsius to Fahrenheit, Kelvin to Celsius. You must memorize all 4 of these. The last one, Kelvin to Celsius and Celsius to Kelvin, these are relatively easy. Okay? So your Fahrenheit to Celsius, you have 5 over 9 multiplied by your Fahrenheit minus 32. Your Celsius to Fahrenheit, you have 9 over 5 multiplied by your Celsius plus 32. Right? Now, remember that PEMDAS.
From Celsius to Fahrenheit is plus 32?
Celsius to Fahrenheit, you have to plus 32. Okay? Do we got that?
Wait 1 second.
Got it?
Yeah.
Okay. This should be our last one. We're going to take some examples. Convert 22 degrees Celsius and 54 degrees Celsius to Fahrenheit and Celsius. Ooh, yes, there you go. And Kelvin.
We're now 54.
So what do we have? 22 degrees Celsius in Fahrenheit. 71.6 for 22 degrees Celsius. Do we have an agreement? How you get 96?
Can you show us how it's done?
Sure.
Yes, C plus 32.
Alright, so we want Celsius to Fahrenheit, right? So the formula is 9/5 times degree Celsius plus 32, right? So we have 9/5 times 22 degrees Celsius plus 32. Remember, PEMDAS. Remember, parentheses, exponents, multiplication, division, addition, subtraction. Which one are we doing first? Ain't nothing in the parentheses but one number. So what do you do first then? Multiply. You're going to multiply 9/5 by 22. What do we get? 39.6. Bring down your plus 32. You add these up. What do you get? 71.6 minus 2 degrees Fahrenheit. Did we get that?
What's the answer for 22?
71.6. Round it up to 72.
Why you do that?
What?
Like 70.6 equal to 72, like.
We gonna get there. We gonna get there. It's gonna be good. We gonna get there. Okay. Now what about 22 degrees Celsius in Kelvin?
It's 295.
Minus 2. 95 Kelvin. Okay. Now what about 54 degrees Celsius into? So you substitute your 22 for your 54 degrees Celsius. 9/5 times 54. What do we get?
97.2.
97.2 minus 2.
Oh, it's degrees Celsius. Fine. Degree Fahrenheit. That's 92 is 129.2 degree Fahrenheit.
129.2
Degree Fahrenheit.
degrees Fahrenheit.
Equal to 129. Equal to 129 degree Fahrenheit.
Good job. 129 Fahrenheit.
Well, science not mean the accurate whatever it is like, because this simple thing is gonna be mess up your whole calculation.
Yes. This is when we get to significant figures. You'll see the beauty of our numbers. Okay? Now what about 54 in terms of Kelvin? 227 Kelvin. Okay? Let's see. And we are done for today. Okay, it is 12:40.